solve question 1b, drawing a diagram will make it much easier to solve it. So here's a diagram I drew a moment ago. So we can see from the question given that there's a rectangle and two semicircles above it. So it asks us for the width, this width, that will minimize the cost of decorating the edges. So to answer this question, we need first to get the area and the cost equation. So the area, for a semicircle is half pi r squared, and we have two semicircles, so half pi r squared plus half pi r squared. And the area for a rectangle is length times width. So to get the width, we know that the width is from the diagram here. We can see there's two semicircles, and like four of and we have here a radius, so we have like four radiuses. So to get the width, we can sub it with 4r. As you can see, here's one radius, one radius, one radius, and one radius, and one radius. So we know that a radius cuts the circle into two parts. So here's like the half of the semicircle, and here's the half of it. So we have here one radius, second radius, third radius, fourth radius. So we can see that the width is equal to 4r. We're trying to solve it for one variable. So area is equal to half times pi r squared plus half times pi r squared, the area for the second semicircle, plus the area for the rectangle, which is 4rw. It's given to us that the area is 32, so we can let a equal to 32 half. We can add those, so half pi r squared plus half pi r squared, we're getting pi r squared plus 4lr. We can here solve for l. We can move the pi r squared to the other side, so it will be 4lr equals to 32 minus pi r squared. We can divide by 4r to isolate 4r, and l equals to 32 minus pi r squared over 4r. So here's the equation for the area. So the reason behind isolating L in this equation is that when we use the cost equation right now, we need only one variable. We can't answer with two variables. So we're now isolating for L, and I will show you why in the next step. So now to get the equation for the cost, so C equals, so the cost for the semicircles, which is 20, the two semicircles is 20. And we know it asks us for the border. So we can see here's the border. So this part is not a part of the border. As you can see, the border is only the outer part. So here. So 20 times the circumference of a circle, which is 2 pi r, plus the perimeter of the rectangle. So this is not included because it's not in the border, so 2l, here we have 2l times 4r. So as you can see here, 10, which is the cost for the rectangle part, 10 times 2l plus 4r. So as you can see here, we can multiply now, so it will be easier. So the cost here is equal to 20 times 2 is equal to 40 pi r plus 2l, this is l, not 21, So 40 pi r plus 20L plus 40 r. So now, as you can see, we can now substitute L here with this L. So L equals 32 minus pi r squared over 4r. So C is equal to 40 pi r plus 20 times 32 minus pi r squared over 4r. Plus 40r. So we can distribute here the 20, so it will be C equals to 40 pi r. So using the calculator, you're going to get 640 plus 640 minus 20 pi r squared over 4r plus 40r. So now to optimize or you can say minimize the cost, we need minimize the width, we need to derive it. So deriving it and letting it equals to 0 will give us the minimum cost when for the radius. So, and we know that the width is equal 4 times the radius. So if we to get the equation, we derive it now, let the cost equals to 0, and then the number we're going to get it, the r value, we will multiply it by 4 as I've told you before, w equals 4r. So let me show you here. So C prime is equal to, we can, by the way, before doing that, we can do something to make deriving it easier, which is 40 pi r plus 640. We can like remove it into like two parts. I will show you now. 640 over 4r minus 20 pi r squared over 4r plus 40r. So doing it like this will make it longer when deriving it. So you can see now. I will show you. C prime is equal to 40 pi, and we know that from the derivative rule, it's r to the power of 1. If we want to derive it, we will multiply it by 1 here, and minus 1 r to the power, which will be 1 minus 1, which will be 0. R to the power 0 will give us 1. So 40 pi plus, a good thing we can do here is we can move the r here upside in the upper part. So we're going to get, so if you do it like that, I will do it in the side here, so I'll show you how to do it. 640 over 4 to the power of I minus 1. So to derive that, we're going to move the negative, here down. So 640 times negative 1, and we're going to minus it by 1, negative 1 minus 1, which will give us negative 2 over 4. So we're going to get 640. We can move it now downside again, negative 640 over 4r minus 2. And you can see we can simplify it more. So as you can see here, 640 over 4 is equal to 160. So we can put it as negative 160 to the power of r negative 2 here. So I'll return back to the equation. So minus, forgot to do that, minus 160 r negative 2. So again here the same thing, I'm going to derive it. So before that, we know that from the exponent rules, we can, when it's division, we can minus the r. So r2 here minus r will give us 1r up, so it will be 20 pi r over 4, and we know 20 over 4 is 5. So, and if we derive r here using the exponent rules, is going to be 5 here, pi times 1, moving it's now to the power of 1, moving it back, and minus 1, we're going to get 1. So minus, and it's minus here, so minus 5 pi plus 40. And we know here we can move the 40 outside, multiply by -1, then 1 minus 1, we're getting 40. So as you have seen here, so we can subtract 40 minus 5 pi, so we're getting c prime is equal to 35 pi minus, I'm going to write it as r squared plus 40. So now we're going to let c prime equals to 0. So letting c prime equals to 0 will give us the critical numbers, or when the slope is 0. So by doing this, we're trying to find the value of r that will give us the lowest cost. And then we multiply the r by 4. So c prime here equals to 0. We can write here 0 times 35 pi minus 160 over r squared plus 40. We can move the negative 160 over r squared to the other side, so it becomes positive. 160 over r squared is equal to 35 pi plus 40. So we can multiply here by r squared to get rid of the r squared here down. 160 is equal to 35 pi plus 40 times r squared. To isolate now for r squared, we can move it to the other side by dividing 35 pi plus 40, and here 35 pi plus 40. Notice that we can factor here a 5, so both are can be factored by a value of 5. So 5 here, so 16 r squared is equal r squared. Let me just delete that, put it a little bit up. R squared is equal to 160 over 5 times 7 pi plus 8. So we can divide here 160 by 5. We're going to get r equal to r squared, sorry, is equal to 32 over 7 pi plus 8. So let me fast check. 160 over 5. 160 over 5, we're going to get 32, yes. So right now we're going to square root both sides here. I'm going to move up a little bit because of the space. R equal to root 32 over root, as we know, like from the rules, from when we square root, we can change this to be a square root up and square root down. So it's going to be 7 pi plus 8, and root 32 is going to give us root 32 is going to give us 4 root 2. So r is equal to 4 root 2. 7 pi plus 8. So to get the domain, we can check. So the equation here, 4 by 2 over 7, 4 over 2, sorry, over 4 square root 2 over square root of 7 pi plus 8 is equal to 1.03294. So let me check using the domain. So r must be always greater than 0. So we know that r always must be greater than 0. And also here we have the value of r here up L equals to 32 minus pi r squared. So this also must be equal to 0. So as you can see here, 32 minus pi r squared is greater than 0. Then here we can move this so it can be positive. So 32 is greater than pi r squared divided by pi r squared here must be less than 32 over pi. I'm going to move it a little bit here. So r must be less than root 32 over pi. So as we can see here, root 32 over pi is equal to 3.19. So we're correct. So we're getting, so the r we got is correct. So let me write the r here, which is equal to 1.0329. So that's the radius, and we said before that the width is 4 times the radius. So we can, let me do it up here, take up some space. 4 times r will give us the width. So here 4 times 4 pi 2 over square root 7 pi plus 8. So if you multiply that, so 4 over 1. So 4 times 4 will give us 16. So the width is equal to 16 pi over 2 over square root of 7 pi plus 8. So this is the answer. You can also get the domain for the width. So width must be greater than 0, and we know that and we know that here the width is 4r. Okay, so 4 times the length, 4 times the length here, 4 times this length will give us, let me check, so we can multiply like after doing it, which is root 32 over pi. From here we got that the r to be less than root 35. We can multiply it by 4, which give us here root 32 over pi times 4, 12.76. So width must be between 0 and 12.766. So that's the domain for the width, and here's the domain for the radius if you want. Where is it? Here, let me write it again clearly. R is between 0 and 32 over pi, square root of 32 over pi here. Let me do it like this so it's clear. So that's how to solve this question. So therefore, the width, oh, we didn't, we multiplied it here. So the width that will minimize the cost is 16 over 2 over 16 square root 2 over 7 pi plus 8. So as you can see here, at the end we can check if the radius is really a minimum by doing by doing the first derivative test here. So the number here was 1.0, let me check, 1.0329, 1.03. We choose a number before it, so we can choose 0 because it will make here the denominator equal to 0. So let's choose -1 here, for example, and 2 here. So as we plug here the value for -1, and we have the equation here, 35 pi minus 160 r squared plus 40. So if we do that, we're going to get, let me add something here, the pi, we're going to get negative number, as you can see. So it's a negative number. Here we're going to get 0, and for 2, $35, which is positive. So this is a minimum. So that shows that this is the minimum, and if we multiply it by 4, we're going to get the width. So that's how to solve question 1B in the assignment video.